Welcome to the 9th section of the academic chemistry class. This one is on chemical quantities, how much of some stuff we have, but it's a count. And in the first video, we're going to talk about how to count things by weighing them out. And this becomes useful when you have large amounts of things that tend to be small. For example, take a extra large bag of M&Ms. I want to know how many M&Ms are in this bag. Oh, and I need the answer in 2 minutes. So the chances of you being able to open the bag and then count all of the M&Ms in 2 minutes or less is pretty small. But there is a way to get this done. You can count the M&Ms by weighing them. And this is if there is a uniform weight for the substance you're looking at. Now, I happen to know, after much experimentation, that the average mass of a plain M&M is 0.87 grams, and so we're going to use that as a defined number. Infinite significant figures. The bag of M&Ms contains 1,588 grams of M&Ms. So I take the total weight and I divide it by the weight of one M&M. I will get the number of M&Ms, which here is 1,825. And once again, after much experimentation, this answer is correct within experimental variation, really 1,825 plus or minus 5 M&Ms. As things get smaller, this technique becomes even more important. Here's a grain of rice. A grain of rice weighs 0.019 grams. Suppose you have a bag of rice. The bag is a 1-pound bag, which happens to be 455 grams. How many grains of rice are in the bag? Even given a much longer time, counting it's not going to be an efficient way to do it. But since I know how much all the rice weighs, and I know the mass of 1 grain of rice, if I take the whole mass and divide it by the mass of 1 grain, I get the value, which happens to be 23,900 grains of rice in the bag. And yes, I have confirmed this experimentally, and this is within experimental error. Let's get even smaller. A water molecule weighs 2.99 times 10 to the minus 23rd grams. How many water molecules are in a bottle of Poland Springs water that happens to be 500 milliliters or a half a liter? Here's where we put things together. We want to count by weighing, but this is in milliliters. But the density of water is 1 gram per milliliter. So volume times density gives you mass. So here would be 500 grams of water. 500 grams of water divided by the mass of 1 molecule of water, 2.99 times 10 to the minus 23 grams, will give you the total number of molecules in that bottle of water, and that is 1.67 times 10 to the 25th molecules, which looks like this many molecules of water. Or stated another way, 16.7 million billion molecules of water. And yet it was easy to count them because all we had to do was weigh it. So here are a couple of problems for you to do. Problem number 1. An iPhone 6s weighs 129 grams. If a store has 35,991 grams of iPhone 6s, how many iPhones are in the store? Go. And the answer is 279 iPhones. How did we get this? Well, we know the mass of all of the phones divided by the mass of 1 phone, and you get the answer of 279 phones. All right, one more. You got a snowflake. And a snowflake weighs 0.0015 grams on average, and we'll use that as the value. The other day when it snowed, you then had to go out and shovel. You shoveled a path that was 1.92 meters wide, about 5 feet. It was 7.69 meters long, about 25 feet long, and about 0.26 meters high. Call that 10 inches. The total mass of that snow was about 325 kilograms, or about 700 pounds. How many snowflakes were shoveled? Go. And the answer is 2.16 times 10 to the 8th snowflakes, or 216 million snowflakes were moved. The mass of the snow was 325 kilograms. We're going to convert that to grams because that's what our snowflake measurement is in, so you multiply it by 1,000 and get 3.25 times 10 to the 5th grams of snowflakes. Take the mass of all of the snowflakes, divide by the mass of 1 snowflake, and you get the answer of 218 million snowflakes, or 2.18 times 10 to the 8th snowflakes. So in review, it is possible to count things by weighing them out if you know the average mass of one unit. Divide the total mass by the mass of one piece, and that gives you the answer. So just sit and stay for a while, think about this. In the next section, we're going to deal with counting by labels, a topic you already know something about.